This is part 2 of solving quadratic equations by graphing. We're on example 4. It says finding zeros of functions. All right, so find the zeros of f, round to the nearest tenth if necessary. All right, so here's our function. F of x equals x minus 3 times x squared minus x minus 2. And they've already got the graph here. So it says find the zeros. So it's going to be -1, +2, and +3. So if it gives you a graph, you can go straight to the answers. If it looks like it crosses at an exact point, it makes it a little easier, but we still need to check it. All right, so you can check it in a couple different ways. All right, so I have already graphed this. I graphed it exactly like it said. X minus 3 times x squared minus x minus 2, and I hit graph. I also changed the window to -5 and -5, and then this one's -5, and I changed this one to 7. This one goes up to 7 because the x-intercept was at 6. But you can see -1, 2, and 3 are the intercepts, and we can find the zeros by looking at the table. So you can determine quickly if these are correct or not. So you can see -1, 0, 2, 0, and 3, 0. So you can justify saying that these are your zeros looking at the table. So that's the easy way to do it. You also, like we did before, you can plug this in and see if you get 0 here. So either way will help you determine if those points are actually crossing at the exact point. And we can see from the table they are. Again, you could take -1, plug it in for x, here, here, and here. If you multiply that out, or you put the numbers in there, you should get 0. If I take 2 and plug 2 in for x, again, I should get 0. If I plug 3 in for x, I should get 0. That's another way to check your answers. All right, B part, we can look at B part, and it looks like here is -3 and -4, and that crosses in between -3 and 4. This one crosses in between 0 and 1. So let's see how we can determine our zeros using our calculator. So if we go to y equals, all right, let's see. Let's type in x squared plus 4x plus 1, and then hit graph. Okay, it should graph in these same positions, and it did. Now, an easy way to figure out what the x-intercepts are is second calculate and go to intersect. Okay, so we want to find, or you could do 0 as well. Let's try 0. Okay, so we want to find the 0 of the function. So we've got to do this twice because it crosses the x-axis twice. So I'm going to do the one to the far left. Right here is where it crosses the x, so I have to be left of that point and hit enter. And then I'm going to scroll to the right of that point. So it's going to isolate, and it's going to find the 0 in between these two lines here. All right, so now it's going to guess. I hit enter one more time, and it says the x is about -3.73. Now it says this is -1e to the -12. That means it's got 12 zeros there. So basically, that's going to round to 0. So that's your 0. Okay, you can see it's right on the line there. So this is just a weird way. It's in scientific notation, but basically it's got all those zeros, be -0.11 zeros, and then a 1. So basically that's going to round to to 0. So this is going to be our 0. So we're going to do -3.73. And usually when you're graphing, it'll tell you the directions. Will say, oh, this one says round to the nearest tenth. So that means I would take off the 3. So -3.7. All right, let's find the other 0 by doing the same thing. So I'm going to do second trace, and I'm going to find my 0. This time I want to find this 0 right here. So I've got to scroll over here. I want to stay to the left of that point. Then I have to scroll to the right of that point. Again, these lines are kind of isolating that area, so it knows that I'm looking for the 0 within that area. And so this one did say 0 this time. And this says, what, negative 0.26. So negative 0.26 would round up, if you had to round it to the nearest tenth, to negative 0.3. So this is going to be or negative 0.3. Let's just change this here to that. All right, so if you have a TI-84 calculator, you can see they're very handy. There's lots of things that you can do and solve problems using your calculator if you know how to use them. Finding approximate zeros is the easiest way would be to graph and find the zeros that way. If you looked at the table, you would see that these are not going to show up in your table because it's actually in between 0 and negative 1, and this is in between negative 3 and negative 4. And we'll go ahead and look at the table so you can see between negative 4 and negative 3, you can tell it crosses by 0, but it doesn't tell you what the exact point is. And from negative 1 to 0 goes from negative 2 to 1. So again, it's going to cross by 0, going from those 2 points, but it wouldn't be an exact answer. So best way is to use your second trace and find the zeros of the function using it that way. Example 5 says modeling real life. So a football player kicks a football 2 feet above the ground with an initial velocity, vertical velocity of 75 feet per second. The function h equals negative t squared plus 75t plus 2 represents the height h in feet of the football after t seconds. Find the height of the football each second after it's kicked. Then estimate when the height of the football is 50 feet, and then using a graph, after how many seconds is the football 50 feet above the ground? All right, so what we want to do is kind of look at the table of values and see after each second what the height of the football is based on this function. So as you know from previous examples, you can graph it by simply plugging it into your calculator. So I've already done this. Y equals negative 16x squared plus 75x plus 2. That's the function given. I've also changed the window. My x's are going from negative 2 to 7, and my y's are going from negative 5 to 100. And I'm also using a scale of 10. So even though it goes up to 100, it's going to look like 10, but it's because it's going by tens. All right, so what does that mean? That means my y values, that's 10, 20, 30, 40, 50, 60, etc. Okay, now these are going by ones. So it says my height is in feet. So this is going to be in feet, how high the football is, and this is time in seconds. All right, so let's look at our table of values. It says, find the height of the football each second after it's kicked. So at first, it's at an initial height of 2, and we said that. Its initial height is at 2 feet. So 0, 2 represents the initial height. So we can scroll down because we really don't need those negative values there. We only need to look at these. After 1 second, it's going to be at 61 feet. After 2 seconds, it's going to be at 88 feet. After 3 seconds, 83 feet. 4 seconds is be 46 feet, and then after 5 seconds it says negative. Well, we know it can't go negative because once it hits the ground, it's at 0 and it stops. So that means it's going to hit the ground sometime between 4 and 5 seconds. So let's keep this table handy here. All right, right, so I have a screenshot here of the table that we just looked at on the calculator. So it says find the height of the football after each second kicked. That's right here. And then it says estimate when the height of the football is 50 feet. So at 0, it's 2 feet. At 1, it's 61 feet. So somewhere between 0 and 1 second, it's going to be at 50 feet. It's also going to come back down 83 to 46. Between 3 and 4 seconds, it's going to be coming back towards the ground and past 50 feet again. So estimate when the height of the football is 50 feet. I'm going to put between 0 and 1 second. All right. And this is A part because we generated a table using the equation. And then it says using a graph after how many seconds is the football 50 feet above the ground. All right, so let's graph this function. And if we hit trace, our little cursor has whatever the x and y value is. So we can just kind of bring this down. Let's go between 0 and 1 second. So as we're going up, there's 61. Okay, so you see at 0.72, it's at 48 feet. And at 0.79, it's at 51 feet. So using a graph after how many seconds is the football 50 feet, let's say about, about 0.7. About 0.7. It doesn't say how to round it. So let's put about 0.75. How many seconds? So it's going to be about 0.75 seconds. The football is above the ground 50 feet. All right, let's find the other location where it's about 50 feet. Now you can see right here, I'm looking at my y value. That's the height of the football. There's 59. Okay, so here it's at 59.5, and here it's at 52.9. All right, so it's going to be about 3.9. So let's say about 3.9 seconds. All right, so if we want to write that, we can say the football, I can spell, the football is 50 feet above the ground after about 0.75 seconds and about, what did I say, 3.9 seconds. And this supports the estimate in part B. All right, so the football is 50 feet above the ground after 0.75 seconds and about 3.9 seconds, and this supports the estimate that we said is between 0 and 1 seconds here. So the 0.75, you know, that supports that answer up there. We probably should have got an estimate for the other side as well, which you can easily do by looking at the graph. Again, it would have been between 3 and 4 seconds, and you can see 3.9 falls between that. So that would support that estimate as well. All right, that's all for example 5. If you have any questions, please let me know.